And I'm like, how's blood go to the heart? Just name the four To the left atrium, to the left ventricle. It comes in from the pulmonary to the left atrium.
Okay.
To the left ventricle.
So we are talking about the blood circulation of blood.
Good morning, Professor.
Good morning, sir. Madam. Okay, so circulation of blood. You know that blood circulates inside the blood vessels, and blood vessels are arteries, veins, and capillaries. In last lecture, we have identified the arteries in the arterial system. Today, we'll identify the major veins. So first, we'll see the veins of your head and neck part. Then we'll see the veins of your upper limb, lower limbs, abdomen, in those areas. Then we'll talk about the hepatic portal circulation. So those are the things we'll go over first. This is the venous system in systemic circulation. That means the veins, those bring the blood, deoxygenated blood from the body to the heart. You know that body to the heart is systemic, part of systemic, right? So veins bring the blood towards the heart. Arteries take the blood away from the heart, right? So they take the blood in opposite direction, or move the blood, transport the blood in opposite direction. That means what? That means the small veins give the blood to larger veins. Make sense? Small veins give the blood to large veins, and then large veins drain the blood to the heart. Give the blood to the heart. In case of arterial system, heart gives the blood to the large arteries, then large arteries give the blood to the smaller arteries, right? So it is in opposite direction. First, we'll see the veins in the upper part of the body. The largest vein that bring the blood into the heart finally are superior vena cava, inferior vena cava, and the coronary sinus. Superior vena cava.
Is that on your picture?
Yeah, superior vena cava just above the heart.
Gotcha.
Inferior vena cava, you see the large vein below the heart. And coronary sinus you don't see, because you know that coronary sinus is short, wide vein in the back of the heart, right? So those three veins give the blood to the right atrium of the heart.
Okay, which one's superior and which one?
Superior vena cava is here.
Yeah, I got that.
Inferior vena cava is this big one, and coronary sinus in the back of the heart. So those are three veins, right? Superior vena cava brings the blood from the upper part of the body to the heart. Inferior vena cava takes the blood from the lower part of the body to the heart. and coronary sinus gets the blood from the wall of the heart and gives to the right atrium. So right atrium receives deoxygenated blood from the body. You know that, right? Right side deals with what kind of blood? Deoxygenated. And atrium receives the blood from outside, right? And ventricle pumps the blood out. So all deoxygenated blood from the body enters into the right atrium. First we'll see the superior vena cava. You see, the superior vena cava divides into two large veins. Those are called the brachiocephalic veins. So right and left brachiocephalic veins. So if this is your heart, this is the superior vena cava, and it divides into what?
Right.
Right and left what? Brachiocephalic veins. So superior vena cava, this is right brachiocephalic vein, this is left brachiocephalic vein. Okay, then brachiocephalic vein divides into two. One is going upwards and another under the clavicle. So which one is subclavian? Under the clavicle, right? That's the subclavian. So this is the subclavian, vein, and this one is called internal jugular. Internal jugular. Same thing in this side. Okay. So brachiocephalic vein divides into subclavian and internal jugular. So you have internal jugular here. So where is the external jugular? There must be external jugular, right? So external jugular is a branch of subclavian. So this is the external jugular. Okay. So now you see you got both internal and external jugular veins. Now you tell me which one will receive deoxygenated blood from internal part of the head. Internal jugular. Which one will receive, it's like internal carotid. Which one will receive deoxygenated blood from the outer part of the head? External. Make sense? This is very reasonable. Okay. So that's why you have two. They're actually similar to internal and external carotids. Okay. Now, from subclavian, also you get another very important vein, that is the vertebral. This is the vertebral vein. Vertebral vein. You remember vertebral artery? Goes to the brain, right? So vertebral vein gets the deoxygenated blood from the brain, inner part of the head. So now you got two here, internal jugular and vertebral. Both will drain the brain, inner part of the head. And internal jugular and vertebral. And external jugular drains the outer structures of the head. There is overlapping, but that's the idea. Okay. Now, subclavian will run under the clavicle and will go to the armpit and will become what? You all know that. Axillary. It's like artery. Axillary vein. axillary vein, and then axillary vein enters into the arm and becomes what? Brachial vein. Very good. Brachial vein. Now, one thing you have here in the venous system, which is absent in arterial system, is from the axillary vein, two other large veins arise. Two other large superficial veins arise.
From the axial?
Axillary. One is called cephalic vein, another is called the basilic vein. Basilic vein. So those two are large veins. Those are superficial, that means under the skin, arise from the axillary vein. You did not see those in arterial system, right? In arterial system, it is very simple: axillary, brachial, then radial and ulnar. So now, if I ask you, in your arm, how many large veins you have here? Three, right? One is brachial vein, right? And another is cephalic, and the other one basilic. So those are three large veins. Now the brachial goes to the forearm and divides into what? Radial and ulnar, okay, like artery. And in the palm, the radial and ulnar, they divide like this. So this is radial, this is ulnar, and join like this, okay? Join like this and form how many arches? Two, okay? So superficial and deep palmar arches. And from the palmar arches, you have distal veins, okay? So distal veins drain the blood into the arch, then to the radial and ulnar. Now, you see here, the cephalic and basilic, they go all the way down like this. They are long veins to the forearm. And in the front of the elbow, the basilic and cephalic, they get connected by a short vein, and that is called median cubital vein. Median cubital vein. Okay? That connects the cephalic and basilic. Now you see in the picture here. This is the cephalic, this is the basilic. In the front of the elbow, they are connected by this one. This one. This is the median cubital vein. Median cubital vein is used to collect the blood for the lab test. We take the blood usually from the median cubital vein, right? You know that from here, because it is superficially located. Okay, so most of the time we collect the blood for lab test from the median cubital vein.
Is there another vein? Is
Second?
it also called like antecubital vein?
Antecubital vein, yeah, same thing. This is the antecubital vein. Okay, so that's the upper part of the body. Okay, but remember again, I am reminding you, in case of venous system, blood goes towards the heart. So starting from the smallest distal to the arches, right? Then radial, ulnar, then cephalic, and this one. Now we'll see the lower part, inferior vena cava. Inferior vena cava, you know, here you have the diaphragm. Your heart sits on the diaphragm, you all know that. So this is the diaphragm. So inferior vena cava pierces the diaphragm and enters into the abdominal cavity.
Pierces the diaphragm.
Yeah, pierces the diaphragm and then enters into the abdominal cavity.
There's a hole in the diaphragm, or
Yeah.
is it all
Definitely there must be holes in the diaphragm. In the diaphragm, you have hole for aorta, you have hole for inferior vena cava, you have hole for esophagus. Okay, so you have those holes. That's the partition. Okay. Okay. So first, from the inferior vena cava, the veins drain the diaphragm. Those are called what? Diaphragm. Phrenic veins. Yeah. You remember in last class I said phrenic. If you hear phrenic, that means diaphragm. So phrenic veins. Phrenic vein. Okay. Gets deoxygenated blood from the diaphragm. Then also you have hepatic veins. Drain deoxygenated blood from which organ? Hepatic liver. So hepatic vein from the liver. Then you have renal from the kidneys, right? Renal veins. You have gonadal veins. You have vertebral veins. Now, in case of suprarenal, there is something different than the arterial system. So this is the suprarenal gland or adrenal gland, you know that, on the top of the kidneys. In right side, the suprarenal vein directly drains into the inferior vena cava. But in left side, what happens? Suprarenal vein, first suprarenal vein takes the blood to the renal vein, and then renal vein takes the blood to the inferior vena cava. So not directly draining um, the blood into.
Wait a minute, you said superior renal vein drains directly into the inferior vena cava?
Yeah.
And what was the second part?
The right one directly, right? Left one
That is the right one.
is, yeah, left one is going to the renal vein. Okay. So we'll see in larger picture how the inferior vena cava drains the blood. Then here you see the lower end of inferior vena cava divides into common iliac veins, right and left, common iliac. It's like arterial system, right? Then common will divide into what? External and internal. Which one is larger? External is larger and goes to the lower limb. Internal gets blood from the pelvic organs. Okay, so internal is smaller and goes to the pelvic cavity, and external iliac vein is larger, much bigger, and goes to the lower limb. Okay. Then what happens in the lower limb? You see, in the lower limb, when it enters into the thigh, it is called femoral vein, right? Femoral vein. Makes sense because that's the femoral part. And from the very upper part of the femoral vein, the longest vein of your body arises from the upper part of the femoral vein, and that is called the great saphenous vein. So let's see here. You see, this is the femoral vein, and from the very upper part, this is the longest vein of the body arises. That is called what? Great saphenous vein. It starts from the upper part of the thigh and goes all the way down to the foot.
What's a second?
I don't know. Must have some meaning. Okay, so this is the longest vein of your body, and it is a superficial vein. That means under the skin. But femoral vein is what? Superficial or deep? Deep vein. So in the very deep part of the thigh. Okay. Now, when the femoral vein goes to the back of the knee. It is called what? Popliteal vein. And from the upper part of the popliteal vein, now another large vein arises from the upper part of the popliteal vein. That is called the small saphenous vein. Since you had great, there must be small. So small saphenous vein arises. And then the popliteal vein divides into anterior and posterior tibial veins. So anterior tibial and posterior tibial. So what happens, this is the femoral vein in the thigh. From the upper part of the femoral vein, the longest vein arises. That is called what? Great saphenous vein, right? And it is superficial vein. And this is the femoral vein, deep one. And it goes to the back of the knee and becomes what? Popliteal vein, right? And from the upper part of the popliteal vein, a superficial vein arises. That is called what? Small saphenous. Make sense? Small saphenous. So this is great saphenous. This is small saphenous. And then the popliteal vein divides into anterior and posterior tibial. Okay, this is anterior tibial, this is posterior tibial, and from the posterior tibial you get another vein, that is the femoral. Okay, so this is anterior tibial, posterior tibial, fibular. So you see, if I ask you in the thigh, how many big veins you have? Deep one is what? And superficial one is the great saphenous. Now if I ask you in your leg, how many large veins you have? This one, great saphenous, is there, right? Because it goes all the way to the foot. So it must be in the leg too. Make sense? Then what? Small saphenous, right? Anterior tibial, posterior tibial, and fibular. So you have all those veins in the leg. Make sense? Great saphenous, small saphenous, anterior tibial, posterior tibial, fibular. Those are the large veins.
All those are considered large veins.
Yeah, those are large veins. Yes. Yeah. Then in the foot, you have dorsal and plantar venous arches. You know from NP1, you remember this is the foot, this is the dorsal surface, right? This is the plantar surface. This is dorsiflexion, plantar flexion. You have learned that, right? So dorsal surface here, in this side you have dorsal venous arch. In the sole of the foot side, you have the plantar venous arch. Okay, and then you get the dorsal and plantar metatarsal veins, and then digital veins. Now you got the idea about the entire venous system in general. Now you will see what happens in the upper part. So it is a repetition now. Basically, we are repeating the same thing. So tell me, superior vena cava receives blood from which part of the body? Upper or lower? Upper part, right? Superior vena cava divides into two what? Brachiocephalic veins, right? And brachiocephalic vein then divides into what? Subclavian and internal jugular. So subclavian goes towards the upper limb, right? And internal jugular towards the head. Make sense? So you have internal jugular. Now there must be external jugular, right? So external jugular comes from what? Subclavian. Make sense? So now we got both external and internal. Make sense? Okay. Then you have another one from subclavian that goes to the brain, collects deoxygenated blood from the brain. That is called the vertebra, right? So internal jugular vertebral from the inner part, external jugular from the outer part of the head. Make sense? Okay. Now subclavian goes where? To the armpit and becomes axillary. And from the axillary, two large veins arise. Definitely axillary continues as brachial, right? And two other branches, cephalic and basilic, right? Those two are the branches. Then axillary becomes what? Brachial. Is it clear? Axillary becomes brachial and two branches, cephalic and basilic. So in the arm you have three large veins, right? Cephalic, basilic, those are superficial, and deep one is what? A brachial. Make sense? Then brachial goes to the forearm and forms the radial and ulnar. And in the palm forms the arches, right? Okay. Then distal. Now, in the front of the elbow, the cephalic and basilic are connected by a short vein. That is called what? Median cubital, right? And so that's the upper limb. Now we'll see the trunk. You see here, this is the inferior vena cava. You see the diaphragm there, it pierces through diaphragm, and the veins getting the deoxygenated blood from the diaphragm, those are called what? Phrenic veins, right? And since these are below the diaphragm, these are inferior phrenic veins. Then you have hepatic veins. We have talked about that. Hepatic veins, and from the liver. And then you have the renal veins, right and left. You see the suprarenal. In this picture, it is more clear. The right suprarenal is directly going to the inferior vena cava, but left one is going where? To the left renal vein. Do you see that? The left suprarenal goes to the left renal vein, but right suprarenal directly goes to the inferior vena cava. Okay?
Why is that?
Why is that? That's how it was from there. We don't know any specific reason for that. There is no explanation of that. That's not the explanation actually.
Is it true?
It is true.
Nature tends to be a little economical, I would say.
But in many cases you'll see very short arteries or veins. They're taking the blood directly. But yeah, so far I did not see any explanation of that. Okay, so that's how it is formed. Okay, then you see the gonadal veins, lumbar veins. So those are the other veins. Now lower end of the inferior vena cava divides into common iliac veins, and then each common iliac divides into external and internal ilia. Okay. Smaller one is the internal, receives deoxygenated blood from the pelvic organs, and external one goes to the thigh and becomes what? In the thigh, femoral vein. And from the very upper part of the femoral vein, you get the longest vein of the body, which is the great saphenous vein, right? It goes all the way to the foot. And then femoral becomes popliteal, and from the upper part of popliteal you get the small saphenous vein. And then popliteal divides into anterior and posterior tibial. Make sense? Anterior and posterior tibial. And anterior tibial forms the dorsal venous arch, because you see here, anterior tibial is the front of the tibia, right? So it will go to the dorsal surface like this and form the arch there. The posterior tibial forms the plantar arch. and from there you get the metatarsal veins. From the dorsal arch, you get the dorsal metatarsal veins, and from the plantar arch, you get the plantar metatarsal veins. And then you get the deep plantar arch. That's the plantar arch. Okay. Hepatic portal system. Hepatic portal system or circulation is the circulation of blood between the gastrointestinal tract and the liver, GI tract and the liver. Now, you already know what kind of blood goes from the intestine or gastrointestinal tract to the liver. The blood that has a lot of nutrient-rich blood. So, nutrients are taken from the intestine or from the gastrointestinal tract to the liver by the hepatic portal circulation. Why is that? Because liver is the main organ where the nutrients are processed first, then sent to other areas. So first the nutrients are processed in the liver. That's why the nutrients are taken there by hepatic portal circulation. Now why we say portal? Just you need to know the portal circulation means we have few portal circulations in our body. If you see the normal circulation, if you see normally what happens, arterioles, then capillary bed, you already know about this capillary bed, and then venule, right? So this is venule, arteriole. So end of arteriole forms the forms the capillaries, and then the venule. And here you have larger arteries. In case of portal circulation, what you see, the artery connect two groups of capillaries. That means you have one group of capillaries here, okay, capillary bed, and in the other end you also have another group of capillary bed. So this is the portal circulation. Portal.
Where's the feeder artery?
So what happens? This is your gastrointestinal tract, GI tract. You know, in GI tract, in the wall, you have many capillaries, capillary beds,
Okay.
and this is the liver. Okay, so this is the liver. The blood goes from the intestine to the liver. The capillaries of the intestine gives the blood to the portal vein, and this vein takes the blood to the liver and gives to the capillary beds of the liver.
So that's why you
Makes
were
sense?
saying before that it has its own squeezing system or whatever.
Right. So normally we see what? Big artery, then arteriole, right? Then the capillary, then venule. But here, in both sides, you have the capillary beds. So that's the portal circulation. So hepatic portal circulation is a major portal system or circulation in our body. Another one in NP1 you must remember, hypothalamus and pituitary are connected by hypothalamo-hypophyseal portal system. Two capillaries, okay, connected by the blood vessel. Now, this is the hepatic portal circulation between the gastrointestinal tract and the liver. Now, you see first the stomach. From the stomach, gastric vein takes the blood and gives to the hepatic portal vein. From the small intestine, you already know those names. superior mesenteric vein, right? You remember I said superior mesenteric is for the small intestine, upper part of the intestine. Inferior mesenteric takes the blood mainly from the large intestine. And all those three, gastric vein, superior mesenteric vein, inferior mesenteric vein, they drain the blood into the hepatic portal vein. You see there, hepatic portal vein, this one. So from the stomach, which vein? Stomach, which vein? Stomach means what? Gastric. Gastric means stomach, right? So gastric vein. Which one from the small intestine? Which vein? Small intestine? Yeah, and which one from the large intestine? Inferior. There is a little bit overlapping, but that's in general. So those three, right? Take the blood from the stomach, small intestine, large intestine, and drain the vein, nutrient-rich vein, blood to the hepatic portal vein. And then hepatic portal vein gives that blood to the liver, takes that blood to the liver. Make sense? Now, remember, sometimes a student confuse between the hepatic vein and hepatic portal vein. Those are two different things, right? Hepatic veins do what? And hepatic portal vein does what?
Hepatic portal vein connects the liver and the GI tract.
Yeah, that means what kind of blood?
Nutrient rich.
Very good.
Hepatic
And
vein,
deoxygenated blood from the liver to the inferior vena cava.
yeah.
Make sense? Deoxygenated blood from the liver to the inferior vena cava. That's the hepatic veins. You got the difference? One must take the deoxygenated blood from the liver to the inferior vena cava. That's the hepatic veins. And the one take the nutrients from the GI tract to the liver. That's the hepatic portal vein. Two different things. Okay, so that's the venous system. Now we'll talk about the capillaries, structure of a capillary, classification of capillaries, capillary bed. We have already talked about the differences between the artery and vein. I wrote on the board. Then we have talked about the blood pressure actually before. So just let's talk about the capillaries. Capillaries are the smallest blood vessels and are responsible for the gas and other chemical exchange of gas and other chemicals like nutrients, hormones, metabolic wastes. Okay, so through the wall of the capillaries, those chemicals, gases and other chemicals can easily pass through the wall of the capillaries. So therefore the wall of the capillary is extremely thin. That helps a lot. If it is thick, those chemicals will not be able to pass.
Simple squamous.
Yes. So the wall of the capillary is formed by a single layer of squamous, flat cells. That means simple squamous. Okay. Now, capillaries usually get connected to each other and form network of capillaries, and that network of capillaries is called the capillary bed. So capillary bed is the network of capillaries. Capillaries very often anastomos get connected to each other.
Anastomos just means
Connected to each other, yes. And the size of the lumen of a capillary is smaller than the size of a red blood cell. That means very narrow, and a red blood cell can only one red blood cell can pass or squeeze through the capillary at a time. And when the red blood cell passes through the capillary, the wall of the red blood cell gets attached to the wall of the capillary because the size of the red blood cell is slightly bigger than the size of the capillary, right? So the membrane of the red blood cell gets attached to the wall of the capillary, and that helps, right, for the gas exchange. Gas can quickly get out or in. That's how the capillaries are structured. Now, in our body, we see three types of capillaries. Continuous capillaries, fenestrated capillaries, and sinusoidal capillaries. We divide the capillaries based on how porous they are. Okay? So, continuous capillaries are least porous. Very small pores are present. Fenestrated capillaries are more porous than the continuous, but sinusoidal capillaries have lot of large holes or pores. So very porous.
So ones that have fewer pores, they tend to be smaller pores as well?
I said it's smaller, yeah.
Smaller, and what about number? Fewer as
Number is not less. Okay, the number is there are many, but size is size. Here the size is the.
well? We're talking about the size of the number, because based on how porous they are.
How big? How big? Yeah, how big the pores are. Okay, so smallest pores are in what? Continuous, right? So continuous will only allow small molecules, small chemicals. Then the fenestrated, then the sinusoidal. Why the wall of the continuous capillary is very small holes are in the wall of the capillaries, continuous capillaries, because many tight junctions hold the cells together. So you know that in tight junctions, the holes are very small. Only very small molecules are allowed to pass through. So fluid and small solutes can pass through the wall of the continuous capillaries. Where you will find the continuous capillaries, you need to remember this. Plenty of continuous capillaries we see in the skin and muscles. Okay. Then a special type of continuous capillaries are present in the brain. Special type of continuous capillaries. Why we say special? Because the continuous capillaries in the brain are less permeable than the continuous capillaries in the muscles and skins. Less permeable than the continuous capillaries in the muscle and the skin. Which is good or bad? What do you think?
Good.
Good, because your brain tissue is highly sensitive. You know that, right? Highly sensitive neural tissue. So if many chemicals can easily enter into the brain tissue, you know there are some chemicals in our body, those are harmful, right? In the blood, can enter easily into the brain tissue and cause the death of the brain tissue, because brain tissue is very sensitive, can easily die. But other tissues in your body, they are more tolerant, they have more tolerance against the chemicals. Yeah.
So is that how like blood-brain barriers form?
Yeah, exactly. So yeah, the blood-brain barrier is nothing but the wall of the continuous capillaries in the brain. Make sense? So blood-brain barrier, the wall between the blood and the brain, right? Blood-brain barrier, where the blood is inside the continuous capillaries, and outside you have the brain tissue, right? So the wall of the continuous capillary is the blood-brain barrier. You know that harmful chemicals are produced in our body, right? Also, you take all different kinds of food, medicines, right? All those foods and medicines have some harmful chemicals. Your body can detoxify them, but they have harmful chemicals too. So, your blood-brain barrier is protecting the brain tissue from those chemicals. So that's the continuous capillary.
We're gonna learn about drug addiction.
You want to learn
Not
drug
now, but
addiction?
you know, in the class.
We can talk about that after the class.
No, I was wondering, is the class, does one of the things?
No, this is not pharmacology class. This is anatomy and
Well, that's-
physiology. So we
yeah,
cannot
but
talk about
your body's reactions,
addiction
stuff like
or
that.
those things, right? But you can take pharmacology. Pharmacology will give you the all information about
Are you
addiction.
teaching it?
We don't offer any. If we do, I can teach you. You can. Yeah, it's a very good subject.
That's interesting.
Pharmacology. Yeah, how the addiction, occurs and by the drug, uh, all those things. Okay, so here you see the wall of a continuous capillary. You see, in between the squamous cells, this is a squamous cell, this is another squamous cell, this is another squamous cell. In between, you have narrow slits or cleft, intercellular, that means in between the cells, okay? Those clefts are very narrow. So only fluid and small, very small solutes can pass through the wall.
Okay, guys, so
Yes, passive. Now, fenestrated capillaries. In fenestrated capillary wall, you will see clefts as well as through the squamous cells, the channels or pores are present. So, two things, clefts in between the cells as well as through the squamous cells, you will see many channels. Where you will find the fenestrated capillaries, where absorption and filtration take place. You know that in the intestine absorption takes place, right? In the kidneys, filtration occurs. Also, you write it down that secretion of hormones. So secretion, yeah, glandular. Secretion, absorption, filtration. Okay,
secretion.
absorption, filtration occur through the wall of the fenestrated capillary. Make sense? So now if you think where you will find absorption occurs where? In the intestine, right? Filtration occurs where? In the kidneys. And secretion occurs from the endocrine glands. Here you see the wall of a fenestrated capillary. You see in between the cells you have clefts like the continuous. Like the continuous capillary you have clefts here. But also you see through the squamous cells you have pores. So you have two types of passages through the squamous cells as well as intercellular fenestrations or clefts. So it must be more porous than the continuous capillaries. Sinusoidal capillaries. Sinusoidal capillaries have large intercellular clefts. The space in between the cells is very big, and where you will find the sinusoidal capillaries in the liver, bone marrow, and the spleen. And through the clefts, red blood cells can pass. So red blood cells can pass through the clefts, can get out or get in. So you see here two things. The clefts are large as well as the pores through the squamous cell are very big. So here the clefts are big, intercellular clefts, and also through the squamous cell the holes are or pores are very big. So the red blood cells can get out or get in through the wall. Now if you know that red blood cells can get out or get in through the wall, you can think in which organs or structures you will find this type of capillaries. Why in the bone marrow? Because we know that red blood cells are produced in the bone marrow and then enters into the blood, right? Inside the blood vessel. So there must be fenestrated sinusoidal capillaries. Make sense? Where the red blood cells die, graveyards and liver, right? So red blood cells must get out, and then macrophages of spleen and liver will engulf them, right? So to die, many of them will get out. So you see, if you just know that red blood cells can pass through the sinusoidal capillary wall, you can think where you will find where the red blood cells are produced and where red blood cells are die. Make sense? In those organs, liver, spleen, bone marrow. Capillary bed is formed by anastomosis of capillaries, and you see here we already know that capillary bed is located between the arteriole and venule. So this is a capillary bed, and exchange of gases and chemicals occur through the wall of the capillary in the capillary bed. So that's why you see the arteriole gives blood to the capillary bed. So this is the arteriole, gives blood to the capillary bed, oxygenated blood, and oxygen gets out, carbon dioxide gets in. So the blood will become deoxygenated, okay, in this side, and then deoxygenated blood will enter into the venule. So this is the capillary bed, and these capillaries, they anastomose, get connected to each other and form the capillary bed. These are called true capillaries. So those capillaries get connected to each other by anastomosis. Those are called true capillaries. But here you see one capillary, this one is taking blood directly from the arteriole to the venule. This is called the met arteriole. This is actually not true capillary, this one. Met arteriole or false capillary, because that one just takes the blood. No exchange occurs through it, through its wall. So met arteriole or false capillary. Those capillaries form network or bed. Those are true capillaries, and exchange occurs through the wall of true capillaries.
So it has to have some exchange of gas in it, right?
Where?
To be a capillary, it has to be a gas.
Right. Yeah. So met arteriole takes directly blood from the arteriole to the vein. But from the met arteriole, the blood enters into the capillary bed also. So here you see when the blood enters from met arteriole into the capillary bed, into true capillary, sphincters are everywhere at the beginning of true capillaries, and those sphincters control how much blood should enter into the bed. So sphincters do what? Control how much blood will enter into the capillary bed. So if the sphincters are constricted, less or more blood will enter into the bed. Less, right? If the sphincters are dilated, relaxed, more blood will flow into the capillary bed. Make sense? When you need more blood to flow in the capillary bed? When you need to give more oxygen, right? More blood should flow, or remove metabolic waste more. So your body can control the amount of flow of blood depending on the need of the tissue. If needs more oxygen, more blood will flow. If needs less blood to flow, it will do that. The sphincters. In the bottom picture you see the sphincters are strongly constricted. So almost no blood is in the capillary bed. So let's stop here. We have talked about the differences between arteries and veins. I have talked about the blood pressure when we talked about the heart, right? So just go over those slides yourself. You will understand it. If you have any problem, you can talk to me. Okay.